Good afternoon, everybody, and thank you very much for joining me for today's session, which is a deep dive on Amazon EC2 Systems Manager. My name is Maitreya Ranganath, and I'm a solution architect. I'm based out of the Dallas office, and today it's my pleasure to go deep on the Systems Manager with you. Just by a show of hands, how many of you have actually are using or evaluating Systems Manager or using run command? I'd say about 10%. So my objective today is to address that, to show you how you can use that, and my hope is that you come away from this session understanding some cases where you can use Systems Manager and understanding how it can help you. So what can you expect from today's session? You'll get an overview of System Manager capabilities and components. We'll walk you through some use cases of each component. I'll also break off and show some demonstrations to show you some of those components in action. And finally, we'll talk about how you can bring all of those components together to realize end-to-end use cases. I have some demos, so it probably will take almost the entire hour, but I'll hang around after this to answer any questions. If we finish early, I can take a few questions. So we've been listening to customers. We had customers come up and speak about how cloud has become the new normal in places like the keynote that we had yesterday. So what's happening is that customers of all sizes, enterprises as well as small customers, are moving to AWS. And they're getting advantage of the benefits of AWS, increased agility, reduced costs, as well as global reach. But there's been a refrain that what we've seen are customers are also trying to manage the systems that they deploy on AWS. And when they do that, the first step they sometimes take is to bring their traditional on-premises tools to manage those systems on AWS. And they also try to do this management, so have a single pane of glass or a single tool that they can use to manage servers both in AWS as well as on-premises. And what happens then is they've shared challenges with us. What they've told us is that many of those traditional tools are not really designed to handle the scalability that comes with AWS or the dynamic nature of the environment in AWS. When systems can come up and come down within a matter of minutes, many of these tools really can't keep up with that pace of change. What happens then is you have to create two different systems, a set of tools perhaps that work well with AWS and a different set of tools that work with on-premises. And when you do that, you don't get a single pane of glass. You don't get visibility across all your resources. What also happens is that when you try to integrate these kinds of tools together, you end up having significant complexity. And finally, many of these on-premises tools have licensing costs, and you kind of have to buy managed servers. And that can quickly become difficult when you try to manage servers that don't exist for very long periods of time, ephemeral servers. So in summary, customers have shared with us that managing cloud and hybrid environments using traditional tool sets is complex and costly. So we heard that feedback loud and clear, and then we said, what can we do about that? And EC2 Systems Manager came out as a result of those discussions. So in summary, EC2 Systems Manager is a set of capabilities, and you'll see it comes in 7 capabilities today, and we'll dive deep on each of those. It allows you to do ongoing operations and managements of systems at scale. This is addressing the responsibility area of managing operating systems and above. So if you look at the shared model that AWS has, that is a responsibility. If you're using a service like EC2, that is your responsibility. So Systems Manager is a tool that can help you on that, to deliver on that responsibility. So it helps you automate all the actions that you need to do for that. It works across both Linux and Windows servers, so it's cross-platform. And it also can work across both systems and servers in EC2 instances, as well as servers that you have on-premises. So it's hybrid in nature. So the name is EC2 Systems Manager, but it's not just EC2. It can be both on-premises as well as EC2. And finally, to address that cost equation, it doesn't cost anything to use the facilities we are going to talk about. Right? Systems Manager is offered to you at no additional cost. You pay for the resources you use. So for example, EC2, you pay for those. You might pay a little bit for storage of the output. And you might pay for things like spinning up servers when you want to take images. And we'll talk about that. But the services themselves come to you as no additional cost, both for on-premises as well as in AWS. So why should you care about Systems Manager? It really comes down to the benefits it provides you. So number one is it supports hybrid architectures. You can use Systems Manager as a uniform way to manage servers both in AWS as well as in on-premises data centers. It's cross-platform, Windows and Linux, several flavors of Linux, and several versions of Windows. It's inherently scalable. It can handle tens or thousands of servers without having any additional complexity that you need to introduce. It's inherently secure. Like every other AWS service, Systems Manager integrates with tools like CloudTrail and with identity and access management. So you use your familiar ways that you have to manage accesses to resources in AWS. You can use the same mechanisms to manage how actions can be done in Systems Manager. Systems Manager makes it really easy for you to write your own automation and extend that to do additional actions, and we'll see examples of that. And finally, a combination of all of that results in lower total cost of ownership. You don't have to pay for licenses. As well, it reduces the amount of manual work that you need to do. So anything that you can automate, that's effort that you can save on, and you can focus on higher order functions, actually what makes your business unique. So these we consider as undifferentiated heavy lifting. You can kind of elevate yourself and do something which is unique to your business. So let's take a look at the System Manager components and use cases. The core to the Systems Manager is the Systems Manager agent. This is a piece of software that you install on the operating system of servers that you want to manage. It supports a bunch of platforms. So it has several flavors of Linux, including Red Hat, CentOS, and SUSE Linux. And it has several versions of Windows. In fact, if you're running on EC2 and you've launched an AMI for Windows subsequent to about mid of 2016, the Systems Manager agent is already included in the AMI that you launch. So you are already enabled to be managed by Systems Manager if you're using Windows on AWS EC2. If you're using Linux, you have to download and install the agent. So it's a few steps to get it from a S3 URL and expand and run that command. And you can script that as part of your user data bootstrapped script. So every instance that you launch will be ready to be managed by Systems Manager. The agent itself is open source. We make the source available in GitHub so you can examine it to see what it's doing under the hood. So once you have an agent installed on a server, be that on EC2 or on-premises, you're now able to take advantage of the capabilities, which are on the next slide. So there's 7 capabilities, and I won't read them all right now, but let's see how they kind of hang together. And that's the next diagram. So the core of Systems Manager is a concept called documents. So documents are JSON files that you can author, which contain a list of commands or actions that you want Systems Manager to do for you. What you can then do is deliver that document to a service. So in this example, let's say you go towards the right, and you deliver that document to a service or a facility called run command. And run command will execute that document on the entire fleet of servers that you define. There are also services like State Manager, Patch Manager, and Automation that can take documents of different types and execute them. We'll dive deeper into each of these. And there are 3 other services that are auxiliary: Parameter Store, which lets you store parameters; Inventory, which lets you get a full inventory of a software; and Maintenance Window, as the name suggests, lets you define maintenance windows and execute them at your schedule. So you might be thinking, what's a document really, right? So let's look at an example. A document is a JSON document, like we said. This is an example of a document which you can deliver and have executed. It has a schema, so it has a schema version. We have updated the schema a couple of times, so it's schema version 2.0 right now. It has a description, and this document takes some input parameters. So in this example, this is a document that installs a particular Windows feature. So the parameter represents the name of the feature that we want to be installed. So you can have a Windows feature like IIS or .NET Framework, and this document will install that on all the servers you specify. Down below are the main steps. So this is one or more steps that you want the document to execute. And here we are taking an example of running a PowerShell script. So this is a Windows PowerShell commandlet that installs the Windows feature that we've named with the feature. And you can see some examples here of parameters being expanded because those double brackets represent the value of the feature that you're going to provide when you run this command. OK, so what we're doing now is we can take this document and deliver that to one of those features we saw on the previous page and have that executed. So the first feature I want to dive deeper on is run command. So this is a core service. We launched that actually a little over 2 years ago. The concept with this is that it lets you securely and remotely manage your servers at scale, both in EC2 as well as in on-premises environments. You represent the actions that you want run command to do in that document, the format we just saw. And then you decide on how many servers or which servers this particular document should be run. Run command will execute that the systems manager agent will run those commands. The output and the success and failure state comes back to run command, and you can see the results in the service console or through a CLI or an API call. What also happens is the output of those commands are also stored. They can be sent to S3, or they can be viewed directly in the console. Run command also has features to make sure that it can control the rate. So if you have a fleet of, say, tens of servers, you can say that run command will run at the most 2 of those commands in parallel. So it kind of spreads that workload over time. And it also has error handling. So you can define how many errors should happen before run command decides that that particular command has failed. It's AWS native. What that really means is that it's integrated with several other AWS services. CloudTrail is a great example, which lets you know which commands were run and who ran them. So you can actually have a very clear audit of all the commands that were executed on your fleet. It also is integrated with IAM, so you can decide to control your access using identity and access management policies to decide who is allowed to run a command and with what conditions, right? So you can let that scope the permissions down. So what are some of the use cases that people are using run command for? The first one that jumps out is that because you now have the ability to remotely execute commands without having to SSH or RDP into servers, you can now turn those services off. So rather than having to have a whole fleet of managed users on each server and having to worry about who's having access to what, and I'm going to have to rotate their keys and things like that, you can eliminate that entire class of problem and say to those users that you can now use run command to run those commands instead of having to log into boxes. Now, because your run command has documents, that's the curated set of actions that you want to allow your users to do. They can't deviate from that. All they can do is run that. So they can't actually log into a box, surf to some site, and download some malicious code because they don't have the ability to do that, which is a nice thing to have. So again, you can run arbitrary bash and PowerShell scripts, and you can use that for various different use cases. And it's really up to your imagination to see how you can use run command to do your work. So some of the use cases that we've seen customers use that for are for operating systems changes. A very common use case is to do automated domain join. So if you use the EC2 console, there's a drop-down in the wizard that lets you automatically join a domain. Behind the scenes, what's really happening is that a run command document is being executed to join your Windows server to a directory services domain. You can manage application changes, and you can also integrate run command with configuration management tools like Ansible, Salt, PowerShell, or DSC. So you can use that to trigger actions to keep your configuration up to date. Here's a blog post link, as well as a diagram that shows you how to replace a Bastion host. So this is a Bastion host or a jump box that traditionally we've had to maintain because users want to go to servers and administer them. What we can do by taking all those actions and making curated lists of documents is eliminate that entire set of Bastion hosts. So that's an entire infrastructure that we don't need to maintain and don't need to worry about securing, because run command lets you kind of have the curated set of commands, as well as very good auditing in terms of who executed what when. So you don't have to have the set of Bastion hosts. And the other thing is, since you do not allow SSH in, that's another vector that you kind of eliminate from consideration. What I'm going to show you now is a walkthrough. So I'm going to switch now to a demo and show you how run command works. So what you're seeing here is I've logged into my AWS account, and I'm in the EC2. I just logged into the EC2 dashboard. So where you find Systems Manager and all its related services and capabilities is on the left side. It comes in 2 parts. You see the Systems Manager services and Systems Manager shared resources. What I'm going to do now is to click on Managed Instances, and it brings up a list of servers that have the SSM agent installed. So these are servers where I've either installed the SSM agent, such as the Linux servers, or I have enabled the SSM agent on Windows. And in order to let SSM agent talk to the SSM service, I need to give those instances an IAM role, which lets it do that. So there's a predefined policy document that you can associate with that IAM role, which lets a server communicate with the SSM APIs and do things like register and appear online. Scrolling down, I also have an Ubuntu virtual machine that's running on my laptop, which kind of represents the on-premises use case. So what you can see here is that it looks identical to all the other instances, except that its instance ID is mi-something rather than just i-something. So from the perspective of Systems Manager, an on-premises server is the same as an EC2 instance. What I can see here are that the agent versions, so we can keep track of agent versions. So that is managed instances. So these are servers on which I can now run systems manager commands. I'm going to show you now documents. So these are the documents, and if you just log into documents, you'll see that there's a long list of documents that AWS provides. So these are documents that we've created for common use cases. For example, in order to be able to patch the SSM agent, which is a common ask, we have a document here called patch SSM agent or update SSM agent. So this is a document that's predefined. All you have to do is run it if you want to run this particular command. Now, you can also author your own documents. So I'm going to show you an example of that, a really simple document which lists the open ports. So essentially, it runs netstat for me. And if I look at the content of the document, you can see the JSON. I'm going to scroll down to show you that. It's very simple. It has the basic preamble here. Main steps, it doesn't take any parameters. What it does is we have two steps here. The first one is a PowerShell script, which runs netstat -a. And I've scoped that down with a precondition to say that this should run only for Windows. And I have a second command called run shell script and scoped down to run on Linux servers to run netstat with a slightly different set of parameters. So this is a multi-platform or cross-platform document that I can run on a fleet of servers. So let's go and run that and see what happens. So I'm going to run command. I'm going to click on run a command, which brings me to this view that lets me select the document. I'll scope it down to look for documents owned by me. This is the same document we talked about earlier, list open ports. And now I need to choose the set of servers on which I want to apply this document. So I can choose the servers in two ways. I can get a full list of managed servers and kind of select them one by one. Or I can choose them by a tag. So choosing by a tag is really powerful because now I'm not constraining it to the set of individual identified servers. It's any server that happens to have that tag when I'm running the command. And this will come in useful when I have scheduled commands later. For now, let me just go and select all of the servers that I have in my managed list. And I can set a couple of other parameters, like how many servers I need to run in parallel. So let's say I put that as 2. I want to stop after 1 error. And I can, in advanced options, write the output to S3. But I'm not interested in just looking at the output, so I run that. What I get back is a command ID, and I can view the result. What I see here is the result of running that command on all the servers that were in my list of servers. Here's an example. What I'm going to do is refresh that and check what happened to the run of this particular command on this particular server. Sorry about that. I think I conflicted with another patching system, so that's what happened here. But that's fine. We can find the output of that here. So this is an example of a previous run. What I can see here is I can look at the output. And this is an example of a Windows server, so it was skipped the Linux step. If I go back to the Windows server, I can see the output here. And so this is the step and the output from the Windows command. So arbitrary commands can be run, and I can capture the output. I can see them in the console, or I can pipe those outputs to S3, where I can further look at them. So at its basic level, what we've done here is used run command to select a command to run, set the number of servers on which I want it to be run, and collected the results back. All right, let's switch back to the presentation now and go through some other components. So the other component I want to talk to you about is state manager. So we saw an example of run command, which is run this particular command right now. But what state manager does is to let you do that on a repeatable basis. So the idea with state manager is that with the document, you can define the rules and the commands that you want to run on a periodic basis. And the idea here is with those commands, you're going to be able to deal with configuration drift. So you can make sure that your instances and servers are in a defined state based on the rules that you define in that state manager document. So instead of having to, say, list ports, let's say I required an action to update the SSM agent every 30 minutes rather. So that's an action that I could deliver to state manager and have that execute every 30 minutes. The second feature here is inventory. And the role of inventory is to collect software inventory of all my servers and present that in a queryable fashion. So I'm able to now query inventory to know what are the software versions, and I can use that information to find out if I have any server with a particular vulnerable version, for example. So let's look at some use cases. State Manager is all about keeping a consistent configuration. And the second thing is making sure that configuration drift is avoided. So an example of that is, let's say that I have a large set of autoscaling group of instances. Those instances come and go, but they happen to be tagged with the autoscaling group ID, because that's what's done automatically. I can set up a State Manager state action that says, run that on all the servers that are belonging to this autoscaling group, and perform an action. So for example, make sure that this SSM agent is updated. And State Manager will now execute that on the schedule and remove that configuration drift. What are some of the use cases of inventory? So obviously, you can discover and audit your software. You're getting detailed information about all the software versions and packages that are installed, including Windows hotfixes. And you can use that information for security and incident analysis. So let's say that there's a high priority CVE that comes out. If you want to quickly tell, am I running any of those impacted vulnerable versions of software, by going to inventory, you can type a query and quickly answer that. What you can also do is, inventory, we recently announced a new feature called Resource Data Sync. The idea here is that rather than having all that data just in inventory, you can also enable that data to be dumped into S3 and in a certain format, which lets it be queryable easily with tools like Amazon Athena, as well as be visualized in a tool like Amazon QuickSight. So here's an example of a QuickSight dashboard that queries inventory and shows that inventory graphically. So I can see here what are the count of instance IDs by publisher, how many servers are from different publishers. And just below there, you can't see all of it. It shows you kind of a heat map of what are the versions of software that are installed. So you can kind of slice and dice that data that is delivered by inventory in any different way that you want. So certainly, you can use our console to query, but you can now bring that into Athena and QuickSight to do further analysis that you want. This is really, really useful if you have hundreds or thousands of servers, and you want to kind of slice and dice them to find out what you need to do in operational work. Let's do a walkthrough now of State Manager and inventory. I'm going to go back to my console now. Oh, you're not seeing that yet? OK, there we go. So I'm going to go and now look at State Manager. And this shows me that there are a few states that are already running or associations that are already present. I'm going to walk you through how you would create such an association. So let's click on Create Association. It looks very similar to Run command, right? The first thing I need to do is, back to the core concept, I need to choose a document. So let's take an example of what I was talking about earlier. Let's say I want to make sure that the EC2, the SSM agent, is updated on all the servers and kept up to date. So we've created a document just for that, which is called Update SSM Agent. I choose that predefined document. I note that it can be run on both Windows and Linux, so it's a cross-platform document. I need to now choose instances by tag. So I choose here to choose instances by tag. So I'm going to choose instances that are tagged with environment equals production. So, and after that, I need to set the schedule. So here, let's say I want this to be done every 30 minutes, and I set that as a schedule. And I create the association. So what happens from now on is any instance that is tagged with environment production will now get this action every 30 minutes, right? And you can now see the result of applying that in the status here. It takes a few seconds to actually go schedule and do that. What I'm going to do is switch back and look at another one of these that I had created earlier and see what has happened. So you can see here that the association was run on the top of the hour, 2 o'clock, and it was successful on all these instances. So these were the 3, say, production instances. And I can click on that instance ID and switch on the association side and see the output of that. So again, it says that one plugin, which is the Update SSM Agent plugin, was present, and one was successful. So this means that that particular update operation either was not necessary, or the package was updated, and the SSM agent version is now at the latest. So that is State Manager in a nutshell. So the use cases really are dependent upon the document that you want to run. So your document in this case was updating software. It could also be things like checking for a particular permission in a particular directory and undoing any changes that could happen. So think of that as something that continuously runs and undoes any drift that could happen in configuration. Let's look at inventory. So back to managed instances. And here's a wizard way of setting up inventory. So what happens really is inventory is another type of SSM document which is scheduled to run. So what really happens when I do the wizard view is that the document is chosen to be the gather software inventory document. And I can now choose which instances to run it on. So again, let's go back to environment equals, let's say in this case, development. What sort of schedule do I want that inventory to be gathered on? So for development servers where a lot of change happens, I might want to do this every 30 minutes. Production servers where I expect less change, I might want to do this every day or every week or a different schedule, depending on what you want. These are the parameters in terms of what type of inventory I want to collect. So I want to make sure that I want to collect information about applications, AWS components that AWS installs, network configuration, Windows updates for Windows servers, detailed information about the instance, and things like custom inventory. So you have the ability to also push custom information about your servers and have that be tracked by inventory. When I click on Setup Inventory, what really happens is that there's a state manager association that now schedules that gather inventory job to happen at the schedule that I said. The end result of all of that is that when I click on the inventory tab here in the console for managed instances, I can see the inventory by filtering on applications. So for example, let us say that I'm interested in what are the apps that are installed on this particular Red Hat server. This is a full list of all the apps. So I can see here the app, I can see the version, I can see the publisher, when was it installed, architecture, URL, and things like that. So that metadata is what inventory collects on my behalf. I can also now filter down and say, OK, let's say I'm interested in finding out what sort of version of OpenSSL do I have. Oops. So that shows me that these are the versions of OpenSSL that I have. So it's 1.01e is what's installed on this particular Red Hat server, right? So what I'm doing here is I'm querying the inventory by selecting a particular instance. So that's great, but I can also go out, I can unclick this, and I can go back and query the inventory on an entire fleet basis. So this is what I'm going to do now. Let's say I wanted to answer the question of which are all the servers that have .NET framework installed. And that's a question we can answer here. So I'm saying, what are the application names that begin with It shows me that there's one server, happens to be Visual Studio, which is probably a dev box that has .NET framework there. What if we have a rule in our enterprise that says we should not have any system with .NET framework less than 4.6 as an example? So we can add another filter here that says application version less than 4.6. Voila, it's the same server. So this is the one that we need to look at a little closely. So when I come back here, I can do the same kind of filtering to see and I can see that this particular server happened to have both 4.5 as well as 4.6. Not a big concern, so we are probably using this for development, but this is something that we can now take action on if this was interesting to us. Another thing I want to show you is I'll clear out these filters. So what we've done is we are now querying what's the information or what's the inventory information right now. Right? That's useful. But what if I wanted to know about the historical view? So let's go back to the Red Hat server and then take a look at, on the right side, it links directly to a service called AWS config. If you used AWS config for other AWS resources, you know that it's a service that tracks changes in your resources over time. So now what happens is that inventory or software inventory also becomes a first-class citizen of the AWS config in terms of how it's tracked. So I'm going to click on the timeline button and let the AWS config UI come up. So what we are looking at here is the inventory changes over time. So you can see here that I launched this server on 23rd. I made a few changes over time. And then this is the inventory view with the timeline view on the left. Let me click on something here, which is 5 changes that happened on 24th. What were they? So you can see here that what's happening is that I had installed the Apache set of programs. So there were a couple of packages that got installed, HTTPD tools, APR util. And you can see here that on that particular day, it went from nothing to that. That means that a new package was installed. I can also see patching happening. So when you have changes where a particular version changes, let's take an example here. You can see that in this case, the SSM agent was patched by my scheduled scripts to go from 847 to 879, right? So this gives you a great timeline view and can help you answer the question of not just what's the version now, what was it 3 weeks ago, and what were the changes that happened because maybe something has happened, I'm troubleshooting something, right? So great way for you to do that. Cool, so that was, in summary, both looking at state manager and inventory. So back to the presentation. We looked at how state manager can be used to schedule jobs to keep your configuration drift in check, as well as inventory can be used to collect information about all your servers and present that in a queryable fashion. 2 more features. There's maintenance window and patch manager. So we all have situations where we need to make changes to systems, but we want to do this at periods of time when the disruption is allowed. So for example, low traffic periods, because maybe we are patching systems and they need to be rebooted. So traditionally, we've had to define these as maintenance windows. We have run books, we have run plans, and someone is going to wake up at night and do that work. So maintenance window really lets you define those rules in the service itself and schedule those tasks to happen at the time that you define, right? So potentially disruptive actions can be scheduled to happen at the schedule that you define. And patch manager is a service that now lets you patch the operating system of your servers based on the rules that you define as well. We'll dive deeper into both of those. So some of the use cases, maintenance window, obviously, you can use that to automatically perform actions during the periods that you define. It has an inherent concept of priority and a list of tasks. So you can define high priority tasks to be executed first, and then low priority tasks. You can define information like what's the duration of the window, and how long before the window closes should I stop executing more tasks. So you can incorporate a lot of those rules within the logic that you define with maintenance window. And patch manager, obviously, is used for patching and managing your operating system versions. So you can use that to manage a core concept called patch baseline. A patch baseline is a set of rules in terms of what patches supplied by your operating system vendor are approved to apply to servers automatically. So you can define, you can select those patches by severity, you can select those patches by classification, and you can define periods of time that the patch baseline should wait before applying a patch to the operating system. So an example of that would be when Windows or Microsoft issues critical updates, wait for 7 days before applying it to my production servers, but wait for 0 days before applying it to my dev servers. That's an example of a patch baseline. I'll show you some examples of patch baselines, and you can always customize those as well. Once you applied those patches, Patch Manager also lets you look at patch compliance. So this helps you answer the question of, once I've defined the rules, how are my servers doing as regards those rules? Have those patches been applied? And how do I stand in terms of which are the patches that are supposed to be applied but are missing? Which are the patches that should have been applied but failed to apply? So patch compliance lets you query that and see that on the console itself. Let's look at Patch Manager and go back to the demo now. So Patch Manager is found here. I'm going to start by looking at patch baselines. What we've defined here are AWS-provided patch baselines. So these represent common logic. The logic I talked about in terms of taking Windows updates 7 days later is represented by this predefined patch baseline called default patch baseline. So this default patch baseline actually applies to all Windows servers if you don't do anything else. So this is the default for Windows. And I'm going to click on the approval rules, and you can see here it says that take all critical and security updates as long as their severity is critical or important. So this severity comes from the operating system vendor. And after that, wait for 7 days before applying it onto the servers. So this basically sets up that rule. And we can now have this patching execute on a maintenance window if we want. Let's take a look at a similar rule for Red Hat, which is another one of those pre-built rules. It looks very similar. It says take any security or bug fix as long as security is critical or important, and again, apply it after 7 days, right? So these are examples of rules that are pre-built. Now, you could go with these rules, or you can also, of course, create your own rule. So here's an example of a rule I created for Windows development, which says I want to take all security updates and all critical updates, no matter what the severity, and I don't want to wait any time before approving. So this gives me kind of much more fast-following kind of idea. The idea here is that I can possibly test these patches in dev before deciding that they go get approved to be applied in prod. Rules also have the ability to do whitelist and blacklist of patches. So patches that match these rules, but you want to blacklist those so they're never installed because maybe they conflict with something else that you're using, you can blacklist those and they'll never be installed. So those rules are represented in patch exceptions. I've not defined any right now, but you can define both approved and rejected patches, which are never going to be installed, even if they are approved by the rules. So once we define a patch baseline, we now need to schedule the patching, and that can be done by running a maintenance window. So let's go back and look at maintenance windows and see how we set that up. So when we create a maintenance window, I'm required to provide a name here. So I'm going to choose unregistered target. So any target that matches the criteria I defined below will be a candidate for maintenance window. And I'm required now to choose a schedule. So I can choose the schedule to be every 30 minutes, or I can say Sunday mornings at 1 a.m. as an example. So let me go ahead and do that as an example. So this is Sunday morning, 1 a.m. UTC, every week. The duration of the patch maintenance window is 4 hours, but I want it to stop executing things at the 3rd hour, so 1 hour before the maintenance window closes. And that's all I need to do to create a maintenance window. Just define the schedule, right, and the properties about that. Once I've defined that, now I need to tell Patch Manager what exactly to do. And I do that by deciding the tasks. So there's one task that we have, which is called apply or run patch baseline. Out here. And the idea with this one is the moment I run this predefined document, what happens is that the patch baselines that are defined for those operating systems, those are executed. Those rules are evaluated, and the operating system is patched to the level that are approved by the rules, right? So this predefined document does that. So this is what I want to be done. I choose that. I say task priority is 1. I'll choose the selecting registered target groups. So I've not done that yet, but let's say that I had a set of target groups. I could choose specific instances and have that run here. I can also choose, based on the document, to scan. So this simply scans for patches that should be applied, or I can choose install, which actually installs those patches. So I can register that task, and I need to choose the role. So this is a role that Patch Manager uses on my behalf to actually run those patching commands. So there's a maintenance window role that I have, and I choose to execute on 2 in parallel and stop after 1 error, right? So there's same kind of semantics as State Manager, and I registered the task. So I think I skipped a step, so let me go back and define the targets. So you define which servers it should run on. I do that by using the tags. So this runs on development servers, and I set the task here to say run the patching task, and I'm done. So let me just Once I've registered the task, now maintenance window is going to wake up on Sunday at 1 a.m. and start executing the task I defined, which is run patch baselines. And run patch baselines is now going to discover the rules that I've set up for that particular patch baseline for that particular operating system and start executing those particular patching operations. I can come back to the managed instances and take a look at the patching actions that have taken place. So let's go back to the Windows server here. And there's a patch tab here that shows me what are the patches that have been installed. So these are 45 patches that were installed by Patch Manager. Some of those were installed ahead of time by, they were already part of the AMI, and some of them were installed by the Patch Manager based on the severity. So if I scope down to severity, I can see here that there was this July roll-up patch update, which was applied and installed on July 22nd. and this was because it was selected by the rules that I had defined. If I do the same thing with Red Hat, I can see, again, that there were 2 critical patches that Patch Manager decided needed to be installed, and those were installed. The status installed here says that these patches were installed on the server. There's another state called missing, which is basically means that those patches are not present on the server. So this is on a server-by-server view. If I want to look at compliance across my fleet, I can come to patch compliance, and I can go to instances here, choose all the instances that I have, and see how they stack up in terms of the rules that I've defined. I'm in a good place here, so all my 5 instances are up to date. There are no missing updates. There are no servers that are in error state. What that means is Patch Manager is running, and all the instances in terms of the rules that I've defined have been patched up to the level that I want, right? And I can click on these instances, see the output of all of those actions to see what patching actions were completed. So to summarize, what we've done here is we've used Patch Manager to define patch baselines. We've also used maintenance window to execute those patches on a schedule that we defined, in this case, once a week on Sunday nights or Sunday mornings, but we could have chosen a much more frequent execution if we wanted to do that. All right, so we'll switch back now to the presentation and talk about one more feature, which is the final capability that comes with Systems Manager, 2 more capabilities. We've talked about so far actions and changes that are happening to running instances. So we ran run command on a set of running instances. Automation takes that problem to the next step, which is updating and managing Amazon machine images. So we can use automation to make sure that Amazon machine images are up to date from a patching perspective, as well as up to date from a software installation perspective. A common task we see customers do is to bake a common set of security or monitoring agents into their AMIs. But over time, those agent versions change. And when you want to patch the operating system, you can combine both of those actions in automation. So the way automation works is you define all your actions that you want to take, starting from an AMI, launching an EC2 instance, performing actions on that EC2 instance, and then finally taking an image of that EC2 instance. That entire step can be represented in one automation document and executed periodically if you want, or on demand if you want. Once you have this capability, what are some of the use cases? Obviously, you can use that to maintain and update your Amazon machine images. But you can also include additional applications. So your own custom code, your monitoring agents, your security agents can be bundled into your AMIs automatically. Instead of manually executing automation, you can integrate that with your CI/CD pipeline. So imagine a use case where you have your application being built by your CI/CD pipeline. The output of that is a binary version of your latest application code. Your requirement is to burn that into an AMI. What you could do is your final step in your build process could trigger the automation flow, which picks up that latest package, installs it on an EC2 instance, takes an image of that, and now you have an Amazon machine image with the latest version of your code. And you can use that to now deploy that to additional servers, or you can update your auto-scaling group to deploy that when new servers are needed, as an example. One of the ways you can extend automation is through Amazon Lambda. So automation steps can also have a call out to a Lambda function where you can do arbitrary actions. So let's say that at the end of our process, we want to take our Amazon machine image, update all the auto-scaling groups associated with that, and deploy it in such a way that a rolling update happens. That's an action that you could script in a Lambda function as one of the steps in your automation workflow. The last feature is parameter store. And this is a service that can be used across all the components we just talked about, as well as with other services. So parameter store at the base of it solves the problem of securely storing and sharing information. And that could be information that's secrets across your fleet of servers. So rather than having things like database passwords or passwords to other systems embedded in configuration files where they can be lost or inadvertently committed to public repositories, what you can do instead is use parameter store to store those parameters. Parameters can be simple key value pairs or key and string pairs or encrypted strings. And encrypted strings are encrypted using key management service. So if you're familiar with KMS or key management service, it's a service that lets you store keys and use them to encrypt and decrypt your secrets. So parameter store under the hood uses that to encrypt and decrypt those encrypted string parameters. You can reference those parameters in documents. So you can use a parameter, a kind of markup to look up SSM parameters and have that value be retrieved from the parameter store and used as a value in any of your documents. You can go further and integrate that with other services. So certain other services like ECS or AWS Lambda have native integration with parameter store, and they can pull parameters and read them into the function if you want. If you're just writing a script, you can also do a direct get parameter API call to get a parameter and decrypt it and use it. So this solves the problem of not having to store secrets. You don't want to store your secrets in a place where they can be lost. You instead store it in parameter store, and you can now use APIs to get at it. The beauty with that is every API, again, goes to CloudTrail. So you know exactly who made a parameter call request, who was accessing a parameter, and at what time, right? So you have the ability to do that. You also have the ability to scope down that, because every call is going to be checked against IAM policies. You can decide that these users or these EC2 instances with IAM roles for EC2 have access to those parameters. A very classic use case is if you're not using directory services, but you want to join directly to Active Directory. In order to do a domain join, you need the domain admin password, which is a sensitive piece of information. It's all powerful. You want to secure that. So a parameter store is a great place to put that parameter, and you can pull that value of the parameter on the fly, use that to join the domain, and forget that. And it won't be persisted anywhere. And you can have full audit on who accessed that parameter and what it was used for. Here's an example of using parameter stores with another service called code deploy. So on the left here, we have that example of using a database password, which is ABCD in this example. And that is stored in parameter store. And we have a fleet of EC2 instances that are configured and deployed. Code is being deployed using AWS code deploy. The example here is that what we have in the deployment is an AppSpec file, which defines pre and post steps. So one of the steps in that file is to do a get parameter call and decrypt the value of that parameter and get the password ABCD, and use that to configure my connection string and forget that from then on. The way that authentication happens is by an EC2 role with specific permissions. So we are giving it permissions to do just those two particular calls, get parameter and decrypt, right? Because we need to decrypt the encrypted parameter. So you can define exactly who is able to get that parameter, and they have to have the correct credentials to be able to do that. So we've talked about 7 features or 7 capabilities of Systems Manager today. Let's look at how it can be integrated with other AWS services. So these are some examples to do that. The first service is CloudWatch events. So many of the capabilities we talked about, like run command, parameter store, can be sources of events. So if you've used CloudWatch events, it's a service that lets you take events from different sources. An example would be EC2 events, systems going up, systems going down, and wire those events up to targets where you can react to those events. So an example of a target will be a Lambda function that is triggered upon a launch of an EC2 instance, which does something to make that EC2 instance ready for use. You can use that same philosophy with events coming from Systems Manager. So an example of that would be you take an event source, let's say the output of run command, or the fact that run command has completed, and you can now pipe that event to something like a Lambda function to do some work. So that's the Systems Manager as a source idea. Systems Manager can also be a target. So right now you can run commands as a result of events coming into CloudWatch events. So let's say that same situation, an EC2 event happened. You want to react to that by running a run command. You can set that up directly in CloudWatch events and have that happen. Let's take a look at a concrete example. Here's an integration with Lambda. So what I'm doing here is I've set up a CloudWatch event rule to trigger a Lambda function. So let's just walk through a little bit of this Lambda function. What it does is it retrieves the event parameter. It lists the output of the command that this event pertained to. So basically calls the run command list output command. And then it writes the output right into CloudWatch logs. So the philosophy here is rather than having to go through each command in the console, I want to look at all the output in CloudWatch logs. And the way you set that up is you set a rule which defines the source event, which is basically Systems Manager, run command. And then you set up the statuses on which it should be triggered. So in this case, it's a status change notification. What that means is run command status has changed from, say, pending to completed or pending to failed. and we set up the output. So that goes to the function that we define, SSM, in this case, email output, but you could also have it as CloudWatch output. And that wires it all up so that every time a run command state changes, that function is going to be invoked. And the end result looks like this. So you have all the output going to CloudWatch logs. So this centralizes all the output from all the run commands that have taken place in one place that I can now query. And I can now have additional things, like I can set up metrics to alert me when many, many run commands are failing. So if the number of failures exceeds, say, 5, I can now have an alert and take a look at that. So that's an example of taking output from Systems Manager run command, passing it through CloudWatch events, sending it to Lambda, and finally having it end up in CloudWatch logs. Here's another example. So a common case is that we want to scan our environments for common vulnerabilities and best practices. So Amazon Inspector is a service that does that. And the way it works is that you run Amazon Inspector on a fleet of servers, and it produces findings. Those findings are things like, I discovered a vulnerable version of a software package, and this is the CVE, or Common Vulnerabilities and Exploits ID for that particular issue. Those findings can now be delivered through to SNS topics, and you can have a Lambda function that is triggered by that, which in a closed loop goes back and runs a command or runs patch to go and patch that particular vulnerability that was found, right? So instead of having to work with vulnerability software that produce lots and lots of PDF documents, having lots of meetings to decide what to do about it, you could actually script the entire process and have that closed loop where a vulnerability is found and patched almost immediately, right? And this can be used for operating systems. It can be used for application patching and other best practices findings that Amazon Inspector surfaces. So we've been working really hard on Systems Manager. So this is a list of recent launches. So Systems Manager announced, the agent announced support for SUSE Linux in the past few weeks. We have hierarchy, tagging, and notification support for parameter store. So what that lets you do is basically organize your parameters in a tree-based structure. So rather than having a flat namespace, it's a hierarchical tree-like namespace, and you can use that to organize your parameters together. So let's say that back to that DB example, you might want to have DB parameters for a parameter for dev and a parameter for prod. So rather than having some sort of naming convention, you can actually have a path that says prod/db password and dev/db password as an example. Notification support is really cool. This lets you track parameter lifecycle. So back to that DB example, let's say that that DB password was updated. Now we have a problem on our hands because now we need to update all the servers that were using that parameter. So what we can do is we can have a notification on the change of that DB parameter value and trigger a function, such as a Lambda function, to go and update all the servers to let them restart or reconnect to the database, pulling down the new value of the parameter, right? So again, we don't have to manually do any of that. We can set up a closed-loop system to do that. We announced cross-platform and multi-step document support. So we saw examples of that where a single document, such as that list open ports document we saw, can be used for both Windows and Linux with variants of the commands for both of them. This is a big one here. Patch Manager supports Linux patching. This came out about 2.5 weeks ago, so we're really proud of that. This was a very common ask. And now what you can do is you can use Patch Manager, as we saw, and compliance as a single pane of glass to look at patching of both Windows and Linux servers, both in AWS as well as on-premises. And the final feature was syncing the inventory data. We saw an example of QuickSight analyzing that data sitting in S3. And you can kind of think of many different use cases. The moment you have the data in a queryable form, you can actually represent your inventory query in SQL. And basically, it's up to you to query that, join that with other information, and produce your reports, as we saw. So we continue to innovate, and we continue to listen to your feedback. So if you have used System Manager or if you have some interesting use cases, please feel free to reach out. We're really keen to hear that. Here are some customers that are using Systems Manager. Obviously, this is not an exhaustive list. These are some customers who are public about having used that. So if you have any interesting use cases, do see me after this. We're always looking for use cases and areas in which we can improve. So to summarize, where is SSM? Systems Manager doesn't have its own console. It's found in the EC2 console, like I showed you. And so do remember that. And in summary, why would you use Systems Manager? It's about managing hybrid infrastructure It's cross-platform, Windows and Linux. It's inherently scalable. It's secure because it's protected by both IAM policies as well as logging in CloudTrail. It makes it easy for you to write automation. We saw examples of that. And the end result of all of that is reduced total cost of ownership. You don't pay for the usage of the service itself. And through automation, the idea is that you can reduce the amount of manual work. I also put a link here to the Management Tools blog, where we have several articles. Some of the articles I pointed out earlier, they appear in the Management Tool blogs. So keep a look at that, and let us know your interesting use cases. So I hope this was useful. Thank you very much. And I'll hang around here for some questions.